Hello guys, welcome to Yebo Tutor live stream. How? I'm so sorry for keeping you guys waiting. There was a technical issue which I was supposed to fix as fast as possible, but I think now everything should be good and proper. I think we are ready to go on this beautiful Tuesday. Let's look at our analytical geometry. Only 30 minutes of your time will be worth it. So if it's your first time to be on the channel, don't forget to like, don't forget to share, and also to forward to your friends and family. Last week we were on a tour, Yebo Tutor tour. We went to approximately 10 schools in Ora Tambo district, and I hope you were able to enjoy with us and you enjoy during the whole process. And most importantly, you'll be able to apply the tricks which you taught you in person. Now let's get down to the business of today. So today we'll be doing analytical geometry. I saw some few questions on analytical geometry which were asked in the group. So if you're not in our group, please do join our WhatsApp group. It's in the description of this video, and also the WhatsApp link, you can find it in this video, or you can just text the number which is also in this video. Don't waste your time. We are here to assist you. Metric 2023, everyone must pass maths and science and physical sciences because they are so essential and important for you to be able to be accepted in university. Now, without wasting much time, let's get down to the business of today. Are you ready, guys? I am super ready. So I will try to do also, I also saw questions on functions as well as analytical geometry. Sorry, and as functions. So we'll look at both of those topics during the course of the week. Maybe Friday or Thursday we'll stream again and do those topics as well, so that guys you can be satisfied and be ready for your test. I know that you guys will be writing your June exams in next month. So let's equip each other. Let's prepare for each other for the next upcoming exams. Let's go. So today, as you can see, we'll be doing analytical geometry. Okay, someone said that they're trying to join. Just give me 2 minutes. Okay, cool. To those who are joining, just type something on the comment section, guys, or you can type on our WhatsApp group so that we can be able to respond to you when you are speaking to us. Okay, please just type so that we can see something. Let's see something. Now, as we can see on the question paper here, it's from Gauteng. So it's question 3. It's 21 marks plus 18 marks. So usually our analytical geometry is always 40 marks, plus or minus 40 marks. So those are just easy marks for you to grab. So as we are waiting for these two guys to join in, we know that from grade 10, grade 11, grade 12, grade 11, we were taught, or we were introduced to the concept of analytical geometry, and we were taught about how to calculate the midpoint, how to calculate the distance between 2 points of a line, how to calculate the gradient of the line between 2 points. We were taught about collinear lines, we were taught about the perpendicular bisectors, we were taught about the tangent, and how to calculate the equation of the line using y minus y1 equal to m open bracket x minus x1. Then we were also taught about how to be able to calculate the gradient of a perpendicular line, and that was quite great. Now, in grade 12, we're introduced to what we call circle geometry, where basically they are more focusing on what do we call this? They are more focusing on calculating the equation of the circle. They are almost focusing on calculating the points of the center, and also to calculate the tangent, equation of the tangent, calculating the gradius of the radius, the gradient of the radius, etc. So let's just jump into the question so that you guys can be able to see what's really going on. Let's see what's going on. Let's go, let's go, let's go, let's go, let's go, let's go. Question number 3. In the diagram below, A is -3 is to K, B is 4 is to 8, C is 5 is to 0, and D is -2 is to -4. Now, these are all the vertices of the parallelogram ABCD, which we are given. Diagonals AC and BC bisect each other at P. We can see that, which means P will be our a midpoint. Then we are also told that the angle of inclinations of AD and BD are alpha and beta respectively. AD cuts on the x-axis at E. F is a point in the fourth quadrant. Okay, cool. Now, determine the gradient of the line. So this is like back what we were taught in grade 11 and grade 12. Now we are just applying the more general things which we were taught back then. So we know that we are doing question number 3. Let's do this. So on question number 3, the first question, which is 3.1, they say that calculate the gradient of line BC. That's easy because we know that the gradient of line BC is always equal to y2 minus y1 divided by x2 minus x1. In this instance, we know the coordinates of B. We also know the coordinates of C. So that makes our life more easy because now, since we know the coordinates of B and the coordinates of C, then we can be able to use the formula y2 minus y1 over x2 minus x1. This will be 8 minus 0 divided by 4 minus 5. Then we get our answer to be -8. So just like that, the gradient of line BC will be equal to -8. Then if 3.2, if the distance between A and B is root 65, calculate the value of K. Oh, come on, guys. They've already given you a hint. So they are telling us the distance of AB is equal to root 65. And what do we know about the distance? We know that the distance of line AB is the same as x2 minus x1 all squared plus y2 minus y1 all squared, or under the square root, is equal to root of 65. Now let's substitute. Now we are given point A and B. So we can say 4 minus 3 all squared plus, what is our y2? It will be 8 minus k all squared equal to root 65. And this is still under the root. So we can remove the root by squaring both sides. Now we have 7 squared. 7 squared plus 8 minus k squared is equal to 65, right? Then from that point, we know that 49 plus, then this is 8 minus k squared is equal to 65. So now let's break down the 8 minus k so that we can have a trinomial. This will be 49 plus, then we break that out. It will be the same as 8 minus k multiplied by 8 minus k. Okay, so 8 times 8 is 64. 8 times negative k is negative 8k. This will also be negative 8k. Then this will be positive k squared. So this will be plus k squared minus 16k plus 64 is equal to 65. Then after that, we can see that this can be k squared minus 16k plus 64 plus 49 minus 65 equal to 0. So 65 minus 65 minus 64, 64 minus 65, that's negative 1, negative 1 plus 49, that will give us positive 48. So now it will be k squared minus 16k plus 48 equal to 0. Then we can look for factors. If you don't know how to find the factors, you just use the bus, which is the quadratic formula, which we always use. The quadratic formula says that k, or in this instance, since we are using k, so it will be k is equal to plus or minus k squared minus, uh, sorry, in this instance it will be it's usually x is equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. So all you can do is to use this master formula, which is called the bus, if you don't know how to find factors. Okay, but if you know how to find factors like me, we know that this will be k, this one will be k. Then also now we can see that that's 48 and that's 16. So definitely that should have 4 here, that should have 12 here. So this definitely should be positive. This one must be negative. Then our k will be equal to negative 4, or our k will be equal to positive 12. But we can actually see where our k is here. Sorry. So our this should be negative also here. So this will be positive 4. Then we have two positives here, positive 12 and positive 4. But as we can see where we have our k and point A, we can see that our k is the positive y value and it's just 4. It can't be 12. So therefore our value of k is equal to 4. Just to recap on this question, I think I was not really fluent enough. So they say that if the distance between points A and B is root 65, calculate the value of k. So what we did is we used to our advantage that we know the distance of k to be equal to 65, root 65, which is here. So after that, we know that how do we calculate the distance between 2 points A and B? We always use what we call the distance, and we use the distance formula. It says that DAB is the same as square root of x2 minus x1 all squared plus y2 minus y1 all squared. Then after that, we substituted the values of a and b in the correct positions. Then after that, we solved for the value of k. Then we ended up having two values of k. K should be positive 4 and k should be positive 12. But looking at where the k value is, then definitely it can't be positive 12, because if it's positive 12, which means it's also above point B, of which k is below point B. So that's why we say that k must be equal to 4. So in other words, we must be able to conclude, after everything is done, we should be able to conclude what's really going on with our method. Okay, now moving forward to the next question. Prove using analytical geometry methods that BP is parallel, or is, sorry, is perpendicular to AC. Where is BP? BP is perpendicular to AC. BP is perpendicular to AC, and it's 3 marks. So we can solve that problem quite fast, because what is important is for us to know the gradient of MD, BD. Then we can also know the gradient of AC. Then if we multiply both gradients and they give us -1, then definitely they are perpendicular to each other. So this is also easy and straightforward, because now we know that we are handling, or we are solving this problem, which is problem this was 3.2, so now we are doing 3.3. So on 3.3 we should calculate the gradient of BD first. because definitely the gradient of BD and the gradient of what do we call the gradient of BP would definitely be the same. So let's calculate the gradient of BD first. We know that it should be y2 minus y1 divided by x2 minus x1. Now it's time for us to substitute. So this will be 8 minus 4 divided by 4 minus 2. Then we get that will be 12 divided by 6. Then we get our gradient of BD to be equal to 2. Then now we should also calculate the gradient of line AC using the same formula, y2 minus y1 divided by x2 minus x1. Now we can now substitute, then we can see it's going to be 4 minus 0 divided by negative 3 minus 5. Then after that we can calculate this definitely should give us a proper answer. 4 divided by negative 8, that's negative 1 over 2. So let's multiply the 2. The gradient of BD is equal to the gradient of BP is equal to 2. So then if we multiply them, then the gradient of BP times the gradient of AC, that will be 2 times negative 1 over 2, which is equal to negative 1. Then therefore we can actually conclude that BP is perpendicular to AC, because we proved that by calculating the gradients of the two lines. So in your June exam, when they ask you how do you calculate or how do you prove that these two lines are perpendicular to each other, you prove that they are perpendicular to each other easily by just calculating the gradient of the two lines, and we multiply the gradient of the two lines. The gradient of the two lines must give us 3 negative 1. Okay, now moving forward to our problem 3.4. Now we are on 3.4. Calculate the coordinates of f if it is given that ACFD, A, C, F, and D is a parallelogram. Okay, this is quite easy and straightforward, because what is important is to know the characteristics of a parallelogram. So we know that if we know the point or the middle point in this instance, then everything else will be easy for us. Okay, so now we should be able to calculate the midpoint, or we are saying that in English, midpoint of AF is the same as the midpoint of DC. Okay, so these two are the same to each other. So now they want us to calculate the coordinates of F, and it's only 2 marks, which means that this is quite easy. So how can we prove, or how can we calculate that for 2 marks? Okay, so let's calculate this thing for 2 marks. So we definitely know that the midpoint of AF will be x plus minus 3 divided by 2, which is equal to negative 2 plus 5 divided by 2. Okay, and also for the same on y part, we know that and y plus 4 divided by 2 is equal to negative 4 plus 0 divided by 2. So someone is asking me, where is all of this coming from? So do you remember that if we know the gradient of the line, or we know the midpoint of the line, we know that always xm is equal to x1 plus x2 divided by 2, and we also know that ym is equal to y1 plus y2 divided by 2. So this is what we are doing right now by doing this step by step, okay, so that you don't get confused. Now in this instance, we can now calculate our x. This will be x minus 3 divided by 2 equal to 5 minus 2. It's 3 over 2. So now we can now solve for our x. This will be 2 x minus 3, because we have cross multiplied, equal to 6. Then x minus 3 is equal to 3, because we divide all through by 2. Then after that, x will be equal to 6 after we have transposed to the other side. Now we calculate the value for y. Now. So how do we calculate the value of y? The same thing applies. So y plus 4 over 2 is equal to negative 4 divided by 2. then y plus 4 over 2 is equal to negative 8. Then y plus 4 is equal to negative 16. Then y will be equal to what after we have solved that? I hope I did solve it. Oh, sorry, this can never, this should be 2, negative 2. Then 2 times negative 2, that will be negative 4. Then negative 4 minus 4 is gonna give us negative 8. So therefore the coordinate of f will be 6 is to negative 8. How did we calculate this? We say that we calculate this question by looking at this perspective here, that xm is equal to x1 plus x2 divided by 2, and ym is equal to y1 plus y2 divided by 2. Then after that we are able to solve this problem which we are dealing with. Then we were able to say that x plus negative 3 divided by 2 is equal to negative 2 plus 5. Then we solved for x, then our x value is 6. Then now on the other side we solved for y, then our y value was negative 8. Then therefore the coordinate of f will be 6 is to negative 8. Did I leave someone behind? Don't hesitate to ask your question. Now, moving forward to calculate the size, which is to the nearest one decimal place. Now we are doing 3.5. 3.5. Let's look at it. Let's look at it. Nothing is hard for us. Euclidean geometry has been made easy by the Yebo Tutor crew. So on 3.5, guys, 3.5 is quite easy because now they are asking you to calculate the angle. Okay, so they want you to just calculate the size of EDO. Where is EDO? EDO, which means they want you to calculate this angle. Let's start by calculating alpha, and also we must calculate beta. Then everything is now easy because now we can actually see that we can, let me just try to draw this so we can see that if we have that EDO, it will be something like this. Then we can see that we have beta here, then we have alpha here. So we can calculate alpha, then we subtract 180 to get this angle here. Then we can calculate beta, then beta will be equal to this angle because they are vertical opposite angles. Then it's gonna be easy for us to calculate this last angle here. Why? Because now it's just going to be the summation of this angle here plus this is equal to 180 degrees. So we can all see that that's easy for all of us. Now let's calculate that. How do we calculate that? We know that we have been taught this from grade 11, and we know that it's essential to know that the gradient of AD is equal to the gradient of BC, which is equal to negative 8. And now we know that tan alpha is equal to negative 8, which is the gradient of the line, or we can just say first, let's say it's equal to the gradient of AD. Then tan alpha is equal to negative 8. Then alpha will be arctan of negative 8. Then we use our Casio calculator. Always use your Casio calculator to be able to solve this. Then I'm getting negative 82,87. But we know that the moment it's negative, we add 180 degrees. Then I'm getting 97,125. Now we have alpha. After we have alpha, we want to have beta now. How can we calculate for the value of beta? So we know that the gradient of BD, we have calculated it already, and it's equal to 2. Now we can also calculate beta by saying beta is equal to the arctan of the gradient of M of BD. Then using our Casio calculator, happy again, this will be of 2. Then we get 63,43 degrees. So now we have two angles now. Then we can also see that angle O1, as I was saying, is going to be equal to 63.43 degrees. Why? They are vertically opposite angles. They are vertically opposite angles because that's what we have seen and deduced from our small triangle which we did here initially, so that you can be able to see that part. Now, moving forward, what do we want? We want E angle D, or which is going to alpha minus beta. Okay, so alpha minus beta, how can we calculate that? We calculate that easily. Why? Because we know that this will be the exterior angle of the triangle. Okay, so our alpha was 97,125 minus 63,43 degrees. Then using our calculator again, what is our answer? 97,125 minus 63,43, then we get 33,695 degrees. So this is the angle which we were calculating all along. So just to go to this problem once more again, guys, in order for us to be able to know, or in order for us to know the angle of the one we are calculating here, so we say that what is crucial or what is important is to understand that if we draw this triangle on its own, something like this. Okay, mine is not perfect, but it's something. So we have beta here. So we can actually see that beta and beta here will be the same. Why? Because they are vertically opposite angles. Then we have alpha here. You could have calculated this initial angle, or you can say that this angle plus this angle is equal to this angle. Why? It's the exterior angle of a triangle. Then still you'll be able to get your answer, your solution. Now let's move forward to the last question, which is 3.6, before we look at circle geometry. So 3.6. Let's go. Calculate the area of triangle ADC. 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 So how can we calculate the area of triangle ADC? So we must know the length AC, and also we must also know the length of DP. Okay, so the distance of AC will be equal to square root again x2 minus x1 all squared plus y2 minus y1 all squared. Now let's go. This should be 5 minus 3 all squared plus 0 minus 4 all squared. Then the distance of AC will be equal to square root of 80, which is also 4 root 5. Now, I must also know the distance of dp. We say we use the same equation, so it will be equal to square root of -2 minus 1 all squared plus -4 minus 2 all squared. Then what is our answer? With our Casio calculator, guys, I'm getting square root 45, which is the same as 3 root 5. Now, from this part, we can actually say that therefore the area of triangle ADC is equal to half base, and in this instance our base is AC, times DP. Bear in mind that we once proved that BP, where is this? BP is perpendicular to AC. So this made our life easy already, because this shows that we have a 90-degree angle formed, making the triangle ADC a right angled triangle. So the moment it's a right angled triangle, which means we can calculate the area using the normal way which we are used to, by saying half base times height. So this will be 1/2 of 4 root 5 times 3 root 5. Then this definitely will be equal to what? With our Casio calculator, I'm getting 30 square meters. this can be square units because we are not told which units are we dealing with. So this was grade 11 work. Now let's look at the grade 12 work. Okay, let's look at our circle geometry. Let's look at the last question of the day. Question number 4. Question number 4. So on question number 4, it goes as saying, um, in the diagram below, the equation of the circle with center N is x squared plus y squared minus 4x minus 2y minus 13 is equal to 0. Okay, cool. Q2 is a tangent. Oh, wow. This is great. Q2 is a tangent to the circle at T, and T and P is a diameter. Okay, we can see that's a diameter. And we are given point P to be 5:4, and it lies on the circle. The first question, write the equation of the circle in the form of x minus a squared plus y minus b squared equal to r squared. This is easy. They gave us this equation in what we call the general form. So in other words, what we are just supposed to do is to complete the square, which is quite pretty easy, because we know that the first step is x squared plus y squared minus 4x minus 2y is equal to 13. We transpose the big numbers. Then now we can write this as x squared minus 4x plus y squared minus 2y equal to 13, just like that. Then after that, we have 4 and we also have negative 2. So this will be x squared minus 4x plus negative 2 squared plus y squared minus 2y plus negative 1 squared is equal to 13. So whatever we do on the other side, we'll also do it on the other side. Then this will be plus negative 2 squared plus negative 1 all squared. This now will be x minus 2 squared plus y minus 1 all squared is equal to 13 plus 2 squared. 2 squared is equal to 4. 1 squared is equal to 1. So 1 plus 13 is equal to 14. 14 plus 4 is equal to 18. Then after that, we can actually see that we have our 18 there. So therefore, we can write this equation in the form of x minus 2 all squared plus y minus 1 all squared is equal to 18. Then we are happy and we get our 3 marks fast, just like that. Write down the coordinates of n and the length of nt. Wow, they should definitely take us serious. The coordinates of n is the center, so the center will be 2:1 according to what you have calculated initially. Now they are asking us to determine the length of nt. Definitely nt is equal to np because they are both ready. According to Euclidean geometry, we know that a line drawn from the center to the circumference is the radius. So nt is equal to np. So we can calculate the length of np. So we can say distance of np is equal to 2 minus 5 squared plus 1 minus 4 squared, or under the square root. Okay, 2 minus 5 squared, we use our Casio calculator again, square root of 2 minus 5 squared plus 1 minus 4 squared, then we get 3 root 2. Okay, we get 3 root 2. So we say that the distance of NP is equal to the distance of NT is equal to 3 root 2. Why? Then you state that it's they are both the radius. Okay, so others will say radius or say it's because they are radii. Okay, then after that you live happily ever after. Now proceeding, guys, we are almost done. Guys, don't hesitate to ask your questions in the group. You can ask us on the chat. It's also helpful for you guys to communicate with us. Now, determine the equation of the tangent QT. This is quite easy. They want us to determine the equation of the tangent QT. How do we do that? We should know the gradient of nt. We should know also the coordinates of point t. So this is easy because already we know the coordinates of n. So let's calculate the coordinates of t. And how are we going to calculate the coordinates of t? We're gonna use the old school, which says that xm is equal to x1 plus x2 divided by 2, and ym is equal to y1 plus y2 divided by 2. So we know that xm and ym is the coordinates of the center. So in this instance, our center is 2 is to 1. So we can use this to our advantage. 2 is equal to x1 plus, what is the x value of point P? Let's look at it. It's 5 divided by 2. Then we have 1 equal to y1 plus 4 divided by 2. Then we can solve for x1 and y1 just like that, because we now know the coordinates of the center, which makes our lives easy. So this will be 4 equal to x1 plus 5. Then this will be 2 equal to y1 plus 4. Then 4 minus 5 is negative 1 equal to x1. Then also 2 minus 4 is negative 2 minus 4 is negative 2. Sorry for that. So negative 2 is equal to y1. So we can actually say then t will be negative 1 is to negative 2. So we have calculated the coordinates of the contact point, which is negative 1 is to negative 2. But now we are not yet done. We must know the gradient of the radius, which is nt. So the gradient of nt will be equal to y2 minus y1, or divided by x2 minus x1. So what was our x value of n? It's 2. Where is it? Yeah, yes, it's 2. So it's going to be, or for y, it's going to be negative 2 minus 1 divided by x2, it's negative 1 minus 2. So that will be negative 3 divided by negative 3, which equal to negative positive 1. Sorry. So since now our gradient is positive 1, which means that we can calculate the gradient of the tangent. So radius times the gradient of the tangent is always equal to negative 1. Always. Why? Radi perpendicular to the tangent. That's why they are always equal to negative 1. The gradient of radius is 1 times the gradient of the tangent is equal to negative 1. Then the gradient of the tangent will be negative 1 divided by 1, and we get negative 1. Now from this point we can use y minus y1 equal to mx minus x1. Then y minus, then we use the contact point. That's why we calculated this point t. So this will be y minus 1 equal to negative 1, x minus 2. Then we have y plus 1 equal to negative x plus 2. Then y is equal to negative x plus 2 minus 1. Then x will be negative x plus 1. I hope I didn't do any mistake. Okay, this will be positive 2. Then negative, oh sorry, so this will be negative, because negative times positive, it's negative. So if this is negative, which means the final answer here will be y equal to negative x minus 3. Then we are all happy. Then now the last question. The circle with center S, A is to B, touches the circle with the center N externally at T. QT is a tangent to both circles, which is quite good. If NS is equal to 3nt, determine the coordinates of S. I love this one. So this one is going to be your homework. So after you're done, you submit in our WhatsApp group, then we can check your answer. The next time during this course of the week, we'll be able to go through your answer and see if you got the answer correct. If it's your first time to tune in, don't forget to subscribe, don't forget to comment, don't forget to share. Don't also forget to join our WhatsApp group. There is a link in the description of this video. We are also available on our YouTube, our Facebook and Instagram and TikTok. We are Yebo Tutor NMU. Thank you so much, guys, for tuning in. Have a blessed night. Have a great evening ahead.